You can fix your insulin resistance, and I'm going to show you how. This is a glucose molecule. This is a fat molecule. If you eat fat and carbohydrates together, you're going to increase your insulin resistance. Your muscles prefer to use fat for fuel. When your muscles are fueled with fat and carbohydrates together, they use the fat, store the carbohydrates, and prevent the rest of the carbohydrates from entering your cells. This drives your blood sugar up. All right, so you just ate yourself a nice, fatty, carb-rich donut. What's going to go on inside your body as your body metabolizes that donut? Well, this is a representation of a muscle cell. Your muscle cells have different types of receptors. In this particular case, we're showing two particular types of receptors, a GLUT4 receptor and a CD36 receptor. So what happens is you just ate your nice, fatty, carbohydrate-rich donut. The carbohydrates and the fats have to get into your cells somehow. So they use these receptors. So insulin opens up the GLUT4 receptor and allows the glucose to enter the cell. Now at the same time, when there's fat in your bloodstream, fat enters your fat cell through the CD36 receptor. So now you have, floating in your muscle cells, you have fat and you have carbohydrates. On the carbohydrate side, what happens when glucose enters your muscle cell? Well, the glucose, there are a couple of things that can happen. The glucose can come back in, and there's really nothing stopping the glucose from exiting the cell right back out from where it came from. So it takes insulin to get the glucose in, but the glucose can go right back out. But let's say it stays inside. So the glucose stays inside your muscle cells. What happens? Well, the cell has a couple of choices. It can either convert the glucose into glycogen, which is basically a glucose molecule connected to another glucose molecule, and it basically forms a chain. Okay? So it can store it as glycogen. Another thing is it can convert the glucose molecule into something called glucose 1-phosphate. And essentially, you have a glucose molecule and a phosphate group. I know this isn't working out very well on camera, but that's okay. So you have a glucose molecule and a phosphate group becomes attached. Bear with me. Becomes attached to the glucose molecule. So now you have this. Well, this setup essentially locks the glucose inside the cell. So now it can't leave back through the GLUT4 receptor like it could before. It basically locks it inside the cell. Okay. So the next step is the muscle cell then converts the glucose 1-phosphate into something called pyruvate. And essentially, through a chemical process, it breaks the glucose down from this into this. Pyruvate is essential for generating, well, it's important for generating energy inside your cell. So what happens is the pyruvate then enters your mitochondria, and it converts the pyruvate into something called acetyl-CoA, and this then generates energy inside the cell. From this, you get cellular respiration. Your body produces carbon dioxide, your body produces water, and then it produces something called citrate. Okay. That's why when you exhale carbon dioxide. All because your body converted the glucose into glucose 1-phosphate, which then converted it into pyruvate, which converted it into acetyl-CoA, and now your mitochondria is processing this, and a waste product is carbon dioxide. So you exhale CO2. That's the glucose side of things. What about the fat side of things? Well, your muscle cells have another receptor called a CD36 receptor. So what happens is in the bloodstream, you have, when you eat a fatty meal, the fats get packaged up into a very large apparatus called a chylomicron. Picture it like a ball. And inside the chylomicrons, you have a bunch of fat, okay? Those chylomicrons then go through your bloodstream and they release the fat into your muscle cells through various processes, okay? So the fat enters your muscle cell and it has a couple of choices. Your muscle cells, what happens from there, your muscle cell can either store it as triglycerides or it can take long-chain fatty acid and through another receptor in your mitochondria, long-chain fatty acid can then go into the mitochondria and your mitochondria can use the fat as fuel. So then it takes the long-chain fatty acid and now it's combined with a coenzyme, and through this process, your mitochondria starts to break down the fat and use that for energy instead. Here's the interesting part. Your muscle cells, really your mitochondria, prefer to use fat for energy and not carbohydrates. It'll take either or, but in particular your mitochondria prefer to use fats instead. So what happens if you eat glucose, if you're eating carbohydrates and you're eating fats, and they're both hitting your cells together? Well, you've got the glucose that comes in and it's converted to pyruvate. You have the long-chain fatty acid that comes in. But the interesting thing that happens is your mitochondria starts converting the long-chain fatty acids into energy, but the acetyl-CoA that's produced prevents the mitochondria from converting the pyruvate from the glucose into energy. So now you have extra pyruvate floating around your mitochondria and inside the cell. So what happens? With all this excess pyruvate, the excess pyruvate can actually spill out of the muscle cells into your bloodstream where your liver repackages it as glucose. So if you consume fat and carbohydrates together, your muscle cells will prioritize metabolizing the fat over the glucose, and the glucose builds back up in your bloodstream. And your glycogen stores go up, and all of that excess carbohydrate gets stored or it stays in your bloodstream, increasing your blood sugar. This is called the Randle cycle. Something else you may notice, as the mitochondria produces energy, there's also something produced called citrate. As the citrate begins to build up, the citrate produces acetyl-CoA, which produces malonyl-CoA, which then blocks the CPT1 receptor from allowing long-chain fatty acid or long-chain fatty acid CoA from entering your mitochondria. So this is called the Randle cycle. Another thing that is worth noting is that when you eat carbohydrates and fat together, something else happens. With all of the buildup in energy, your mitochondria produces citrate, which through a series of chemical processes prevents the fat from entering the mitochondria. When the fat is prevented from entering the mitochondria, you get a buildup in triglycerides in your muscle cells. So your muscles prefer to consume fat over carbohydrates. If it's both, if your muscle cells are exposed to both, then your muscle cells will prioritize use of the fat and store the glucose. Your muscles know, the cells in your body know when it's time to feast, and if it's feasting, it's time to store energy. That's the whole point. You can see this undercurrent. This is called the Randle cycle. Like I said, you can see an undercurrent of seasonality to this. Your physiology evolved in a seasonal environment. There was summer, there was winter, there was daylight, there was nighttime. Okay? Your body knows that when it's summertime and there's an excess of glucose and fats going on, your body is going to naturally want to store all of the excess energy that it can. This is really what's going on with the Randle cycle. But it's important to know because when you consume both, when you consume carbohydrates with fats together, you increase your insulin resistance. Your sugar goes up. I'm going to show you another example here in just a second. So we talked about what's going on inside your cells when you consume fat and carbohydrates. What about at a more macro level? This chart here represents a muscle cell, your blood, and a fat cell. So the column on the left is a muscle cell. The column on the right is a fat cell. And the column in the middle represents your blood. Okay. All right. So what happens? You just had that carbohydrate-rich, fat-rich donut. What's going on? Well, the carbohydrates and the fat are in your bloodstream. Okay? The carbohydrates try to get into your muscle cell, and the fat tries to get into your muscle cell. So now you have both inside your muscle cell. As a result of your muscle cell trying to metabolize the fat, it prevents the glucose from being metabolized. So you get an increase in glucose. Okay? But since you have an increase in glucose and as a result of insulin, your glucose also tries to get into your fat cell, which prevents your fat cells from breaking down the triglycerides into long-chain fatty acids. And what is a triglyceride, by the way, just to add that on? This is essentially fat, and a triglyceride is one of those, actually three of them. You've got 1, 2, 3, and all three are connected to what's called a glycerol. Basically, we call it a glycerol backbone. Okay? So when your fat cells break down fat, it essentially starts to break these off so that these long-chain fatty acids can then come into your bloodstream. So the long-chain fatty acids then come into your bloodstream, and then they enter your fat cells. Okay? But what happens is when you consume carbohydrates and fat, your body stores the glucose, your blood sugar goes up, and it prefers to burn the fat. This is why when you consume a meal that's high in fat and carbohydrates together, your blood sugar goes up and your insulin resistance goes up. So what can we do about that? What are our options? Well, we're going to go into that in the next section. So how many different types of diets are there out there? There's vegan, there's keto, there's carnivore, Would it surprise you to know that there are really only 4 types of diets? All diets really fit into only 4 categories. And I'm going to show you what those 4 categories are. Essentially, you have 4 categories. Okay? There are 4 possibilities. You can have a diet that's high in fat. You can have a diet that's low in fat. You can have a diet that's high carb. And you can have a diet that's low carb. Okay. So, a diet that's low carb and low fat, one example would be carnivore. Okay. What about a diet that's high carb, low fat? Big one would be, say, vegan 80-20 or any type of 80-20. Vegan 80-20, or like I said, any type of 80-20 diet. Another example would be low carb, high fat, or high carb, high fat. What would be low carbohydrate, high fat? Well, an example of that would be keto. High carb, high fat. High carb, high fat diet is basically the typical American diet, right? So you've got what they call the SAD diet, right? That's your typical American diet. And with high carb, high fat, you get a major amount of insulin resistance. Okay. Why? Because you're eating fats and you're eating carbohydrates together. So if this isn't a good idea, maybe it is, maybe it isn't. We'll get to that in a second. But assuming that this isn't a good idea, what other options do we have? Well, another possibility would be low fat, high carbohydrates in the summer, which would be seasonal. Or you could say seasonal raw vegan. Or any type of seasonal diet, really. Another option would be low fat, low carbohydrate, low fat. Another example would be seasonal / seasonal raw vegan. And high fat, low carbohydrate. Another example would be seasonal or seasonal raw vegan. So I want you to notice something. Many diets out there we talked about in a previous video that a lot of diets want to lock you into a particular physiology. And they do that by locking you into a particular season, okay? You could consider high fat, high carbohydrate, you could consider that a summer diet. And you could consider low carb, low fat, you could consider this winter. Carnivore diet, the only thing that's around is meat. Well, you could consider that a winter diet as well, if there's no fruit available. And then you have low fat, high carb. This could be summer, it could be spring, it could be fall, right? And a low carbohydrate, high fat diet, I mean, that could be late fall, that could be late summer, depending on where you are in the world. So you notice that there's a seasonality to all of this, okay? So you have a carnivore diet that locks you into one particular season. You have a typical American diet, which locks you into a particular season. You have keto, which locks you into a winter season. You only have one type of diet that allows you to cycle through all 4 seasons. And that would be some type of seasonal diet. I would recommend seasonal raw vegan, but that's just me. But any diet with a seasonal variation is the only type of diet that allows you to go through that cycle. All other diets lock you into a particular season. Okay, so How does that affect you? How does that affect your insulin resistance? And how do we get rid of that insulin resistance? I'm going to show you a couple of facts in the next part of the video. All right, so what are the benefits of eating seasonally? You get a lower blood sugar, you get a lower blood pressure, you decrease your cholesterol, at least in the winter, because you're reducing your carbohydrate intake in the winter. You lower the likelihood of a heart attack, you lower the likelihood of stroke, you lose weight, and essentially you lessen your insulin resistance. How do you do this? How do you go about getting all of these benefits? I would say keep in mind 4 important points. One would be to eat seasonally. I mean, yes, I'm a raw vegan. I would recommend eating raw vegan. That's what I do. But I would recommend eating seasonally. Even though you're eating raw vegan, you can still eat on a seasonal basis. Fruits in the summer and more vegetables in the winter. Okay? Don't eat carbohydrates and fats together unless it's the summertime. There are a lot of vegans out there, a lot of raw vegans that they're stuck on the 80-10-10. They're stuck on high carbohydrates, no fats. Your body needs some fats, but you can eat it seasonally. You can eat these things seasonally. So eat seasonally. Don't combine carbohydrates and fats together unless it's summertime. Increase your vegetable intake in the winter and increase your fruit intake in the summer. Kind of a shorter video today, folks, but I think there are some interesting things to learn through the Randle cycle and a lot of metabolism that goes on inside of your body cells. For more videos that'll help you get and stay healthy, please subscribe to my channel. I'll see you in the next video.